Hello friends, in today's lecture we will discuss how to calculate bolt tightening torque. Basically there is a bolted connection here and this bolted connection consists of plate 1 and this is basically plate 2 and there is a bolt inserted and is a bolted joint. Now what we are doing, we are tightening up this bolt. Okay, there is bolt and nut, we are tightening up this bolt. Okay, we are providing some torque. Tightening means we are providing some torque. When we are providing some torque, then this bolt, it is fixed at this end, so it will be try to elongate, it will be try to pull out. Okay, so it will be in tension. As shown, it will be in tension, and as this bolt is in tension, the nut, this head of this bolt will insert or will exert a force on the plates, and these plates will be in compression. So when we give torque, this bolt will be in tension, this bolt will be in tension, and these plate will be exerting. Okay, these plates will be exerting force on each other. Okay, so this is the basic funda of a bolted connection. Now in this term there are two terms that we must understand. One is the preload and the other is the clamping force. Clamping force. Okay, what exactly is preload? Preload is just like a tensile load. Okay, preload is basically tensile load. So preload, the tensile load, preload is basically the tensile load developed in the bolt due to tightening torque. Okay, so whenever we are providing some tightening torque, there is a tensile load developed in the bolt, and that tensile load is called as preload. And the other is the clamping force. Clamping force is basically the compressive force between the two plates that hold together them, is basically the clamping force. So hope this is clear to you, what exactly is preload and what exactly is a clamping force. Now we are providing, when we tight up, when we are giving some maximum value of torque to a bolt. Now out of this total torque provided to a bolt, there is not like this the whole torque is going to this preload. No, whole torque is not converted into preload. There is a some chart or there is some presentation of this. Okay, let us suppose there is a curve. Okay, this is the curve between torque that we are providing and number of turns. Okay, it is simple things. As we are increasing the torque, the number of turns keeps on increasing. Okay, now out of that, this is the this is basically, this level is the maximum total torque. This is basically the maximum total torque or the maximum preload that we are providing by tightening the by giving the torque. Okay, this is the maximum torque that we are providing. Then out of this maximum torque that we are providing up, around 50% is goes waste or is goes in nut friction. 50% goes in nut friction, in overcoming the friction between the nut and the bolt. Okay, now 40% lost in the thread friction. 40% lost in thread, the friction between the threads, thread friction, the 40% is lost. Only this 10% have a useful value. This only 10% is the useful torque that is coming on to the bolt, that keeps on helping the bolt inserted. So identifying the torque that we have to provide is a very important, and very important because only the 10% of the total applied torque is going up there. Okay, hope you understand this. Okay, torque versus turn. Now in order to identify the torque that we have to provide it, there is a formula, there is simple formula, and this formula is T is equal to KDF by 1000. T is the torque, KDF by 1000. Understand, kindly understand all these terms. K is basically nut factor. Okay, with the bolt we are providing some nut. Okay, D is the nominal bolt diameter, mm. Okay, and F is the preload, and this preload we have to calculate. Okay, by 1000. So in order to identify what torque we have to provide onto a bolt, we first have to find this K, nut factor. There is a manual provided with the bolt, and from the agency you have provided the bolt, they will give you the nut factor details, and this nut factor depends upon the what is the fastening material, what material it is made up of. Okay, what is the coating on that Okay, and what is the type of lubrication they are provided between the bolts. Okay, so this is basically depends upon the nut factor. It is less than 1. So this nut factor is provided by which agency? From which you have buy up the bolt, they will provide the value of the K. Nominal bolt diameter, as you are purchasing some bolt, the diameter is generally expressed. It is basically the specification of the bolt. You can easily identify D. Now F, we have to calculate the F, preload, and this preload is also calculated using the properties of the material that we are, from which the bolt is basically made up of. Okay, now we will understand how this preload is being calculated. Okay, now before understanding the preload, the concept of the preload, we first have to understand the concept of the proof strength. Okay, then you are able to understand the concept of the preload. If you know, we are generally made of elastic material. Okay, now for a simple, the stress strain curve is like this only, A B C. If B is the yielding point over A. Okay, if we we give the torque to a bolt in such a manner, the preload developed in the bolt is more than its yielding point load, then the bolt will permanently elongate. So what we does, we always have to provide the load less than the yield point of the material. So what basically we provide, we basically provide a proof strength. This is basically the yield strength. Okay, yield strength. So we have to provide, and we have to identify the load, this F in the formula, using the concept of proof strength only. From the proof strength we will identify the proof load. So we have to first identify what is the proof strength. So proof strength can be defined as the maximum tensile stress that can be applied to a bolt which will not result in plastic deformation. Okay, so we have to provide the load below this B point, down this B point only. So in order to identify the proof strength, it is normally a formula. It is normally done 0.1 to 0.2% offset is taken. 0.1 or maximum 0.2% offset is taken. A parallel line is drawn, and at this line, whatever the point this cuts up, that will be the proof strength. Okay, so in this way we are able to identify, or the proof strength for the material can be easily identified. Okay, and this proof strength is generally 85 to 80% of the sigma by, because we are not able to identify the yield strength. So if the material is known, you can identify the sigma y is given. From that you can easily identify the proof strength. So that is basically proof strength sigma p. Okay, now what is sigma is given by force over area. If you know the sigma p, if you know this sigma p is the proof strength, you have to calculate the sigma fp. What f is the, that is to be provided, that has to be put there. Okay, fp, you have to find the fp. So sigma p is equal to fp over area. You know this sigma p. Okay, this is using this stress strain diagram. You usually know it is basically 0.85 to 80% of yield strength, sigma by. Now you have to multiply this sigma p into a, you will get fp. So fp, what is fp, is equal to sigma p into a. Now what is a? Area. A is the area, that area of the bolt that is under stress. Okay, now area of the bolt that is under stress. So fp is equal to sigma p into area, and this area is calculated using this formula. This area under stress is A is equal to pi into d minus 0.9832 p bracket में इसका square divided by 4. Okay, all these terms are known. D is the nominal diameter, p is the pitch. Okay, you have to identify this. So you have to, when you calculate this area, you have to just put in over there fp is equal to sigma p into area. In this way your fp is calculated. Now you don't have to directly put f over there. There is one more thing that we have to consider. There are two cases where the bolt can be reused, or the bolt serve the purpose only once it can be used only. Basically there are two cases. One is the bolt you want to reuse it, and the second, the bolt not to be used again, single use only. When you want to reuse, then you have to use only 75% of the proof load, that the load that we have calculated, that is 0.75 fp. If you want to only use for a single time, then 0.9 fp. Okay, now always remember, if you are providing the forces or the preload, okay, that is 0.9 fp, then you can't reuse the bolt again. Okay, if you are torquing the bolt and developing a tensile load of around 0.9 p of the proof strength, okay, then you can't use the bolt again. If it is less than 0.9 fp, or if you are using only 0.75 or 75% of the proof load, then you can again reuse the bolt. This is the basic funda. Okay, so in this way you are able to the preload f is 0.75 into proof strength into bolt stress area. If preload f is 0.90 into area, it is a condition where you want to reuse. Okay, and it is the condition where you are using only single. Okay, in this way f is calculated. Now you have everything. You have k value, you have d value, you have f value. You can easily calculate the torque that you have to provide to the bolt for the tightening purpose. Okay, hope you like this video. Keep supporting, subscribe. Thank you.